Welcome to this video on solving equations that contain exponents. Let's begin. In the last chapter, we undid a square root by squaring both sides. Likewise, if we had a cube root, we undid this operation by cubing both sides. But what if we wanted to solve something like this? X plus 5 quantity to the third power equals 64. The question is, how do we get rid of that third power? How do we undo raising something to the third power? Anytime we want to undo an operation in math, we have to employ the inverse operation. Let's review some of the inverse operations with which we are already familiar. So, for example, we know that if we want to undo addition, we use subtraction, and vice versa. That's because addition and subtraction are inverse operations of each other. Likewise, if we want to undo multiplication, we divide, and vice versa. Again, multiplication and division are inverse operations from each other. But what about exponents? What is the inverse operation? Well, the inverse operation of an exponent is a root, and the inverse operation of a root is an exponent. Okay, so if you're like, well, what is a root? What is an exponent? Well, let's just remember. So if I have x squared, right, that is an exponent. So to undo the x squared, I would need to take the square root. Okay. Likewise, if I have, let's say, x to the third power, to undo x to the third power, I would have to find the third root of that. So that's what we mean by exponents and what we mean by roots. So let's do some practice here. So I have the square root of x. How would I undo the square root of x? Well, I'd have to square it. How would I undo the third root of x? Well, I'd have to raise it to the third power. How would I undo the fourth root of x? I would have to raise it to the fourth power. Okay, what about x squared? How do I undo x squared? I need to take the square root. I need to undo x to the third by taking the third root, and I undo x to the fourth by taking the fourth root. So let's look at example 1. So you just saw this a few slides ago. We have x plus 5 quantity cubed equals 64. And as we just discussed at length, the way we undo the raising to the third power, the cube, is by taking the cube root of both sides. So this is going to give us x plus 5 is equal to the cube root of 64. You can do that in your head or on your calculator. You get 4. So now we have a simple one-step linear equation, which we can solve by subtracting 5 from both sides of the equation. So we have x equals -1, and that's our final answer. Let's look at example 2. I want you to take a minute and think about how is this example a little bit different from example 1. Pause the video, write down your answer, and then unpause it to see if you were right. Well, one difference you might notice is that there's an x plus 5 and not just a single value in the parentheses. But the difference that I was talking about, maybe slightly less noticeable, is that we have an x squared here, and in the previous problem we had a third power or a cube. And that might not seem like a very big difference, but it's actually is a very big difference, and I'll show you why in a second. Okay, so to undo a square, of course, we need to take the square root, and we have to do that to both sides of the equation. So you might think, okay, well, my answer is just x is equal to 4. Okay, so I'm going to write that, and then I'm going to kind of put some question marks around it. Okay, so here's what I want you to think about. It is true that 4 times 4 is equal to 16. That is a true fact. But there is another number that when multiplied by itself gives you positive 16. Just for fun, pause the video and see if you can figure out what it is. So that number is -4. -4 times itself is still positive 16, isn't it? So we can't just say that x is equal to 4. One way to do it, one way to express this, is we can say that the absolute value of x is equal to 4. Right? Remember, absolute value is the distance from 0 on the number line. So x, in this case, could be positive 4 or -4. So sometimes we will use this notation, the plus or minus, to write our answer. An equally valid way, you could write it as -4, comma, positive 4. Okay? If you don't want to if you don't want to write the absolute value part, you can go straight from the square root to writing the plus and minus solutions, or straight from here to writing it like that. Okay, and just to prove it to you, right, just to show you that I'm not lying, -4 quantity squared is 16, so that's still true. positive 4 quantity squared is also 16. So both of those answers are correct. So let's see if we can summarize the information that we just discovered in examples 1 and 2. So if I have an even root, I expect how many solutions? Well, I expect 2 solutions. And if I have an odd root, like the first example, I only expect to have 1 solution. Okay, so our example here was x squared is equal to 16. And so we have x is equal to either positive or negative 4. And the reason that this is true is because positive 4 times positive 4 is 16, but negative 4 times negative 4 is also positive 16. So again, you can write your answer like this, plus or minus, or you can write it with comma separated values, 4 comma negative 4, or negative 4 comma 4. Either one of these is fine. I don't care. Don't write both, just pick one. Okay? So for the odd root, I'm going to pick a very, very basic example. I'm just going to say x cubed is equal to 1, right? So how come with an odd root, I don't have to write x is plus or minus 1? How come I don't have to do that? Well, I'm going to show you. So if I have 1 times 1 times 1, right, that gives me 1, right? That's x to the third power. What if I had negative 1 times negative 1 times negative 1? What would that give us? Well, a negative times a negative is a positive, right? And then 1 times negative 1 is negative 1. So notice, right, the negatives don't give us a positive because there's an odd number of them. So again, in this case, we only have 1 solution, not 2. So this is just a really important piece of information. Make sure you have it in your notes. Make sure you kind of memorize it. Maybe make flashcards out of it. If you have an even exponent and you're taking the root, you're going to end up with 2 solutions. If you have an odd exponent and you're taking the odd root, you're going to have 1 solution. So let's do some more examples so we can practice remembering this and applying it in more examples. Okay, so we have example 3. So the first thing that I want to encourage you to do before you just get cracking and start solving this is to ask yourself, at the end of this problem, how many solutions do I expect to have, right? And that's based on that number right there that I just circled. So if I have an odd exponent, right, 3 is odd. It's an odd number, not an even number, right? So that means I'm going to expect to have 1 and not 2 solutions. I don't know why I put an S there. That's silly. Okay, I'm going to expect to have 1 solution. So this is important because sometimes you're on a roll, you're working really hard, and then you just forget. You forget that you have an even exponent. You forget to put in that plus or minus, and then you lose a bunch of points because, you didn't do the whole problem. Okay, so this is just a good way to remind yourself before you start any of these sorts of problems. Stop and ask yourself, how many solutions is this going to give me? Okay, so as you can see, I'm taking the cube root of both sides. That gives me 2x plus 3 is equal to, and again, you can use a calculator or your head for this. The cube root of 27, believe it or not, is 3. So then we have a 2-step linear equation. We subtract 3 from both sides. We get 2x is equal to 0. We divide by 2, and 0 divided by 2, of course, is just 0. So that's our solution. Again, we only have 1 solution, which is what we expected. Okay. Just remember, you can always check your work just to verify that you did it correctly, so you can walk away from a test, a quiz, or a homework knowing that you got the right answer. Okay. This isn't like where we had extraneous solutions and we have to check every time. This is just, just best practices. Okay. So 2 times 0 is 0. 0 plus 3 is 3. And of course, 3 cubed is, in fact, 27. Okay. So again, you can always check your work just to, make sure that you did it correctly. All right, let's look at another example. So again, before I get into wading into this problem and starting to solve it, I'm going to look at this exponent and I'm going to ask myself, how many solutions do you expect to find? Right? Well, 2 is an even number, and anytime I have an even exponent, right, and then I'm taking the even root of both sides, I expect to have not 1 but 2 solutions. Okay, so I'm going to write that down for myself so that at the end, if, I get distracted, answer the phone, answer an email, do something in between, and I come back to the problem, I make sure that I have both solutions, not just 1. Okay? All right, so we have 2x plus 4, quantity squared equals 36. Okay? So remember to undo the square, we have to take the square root. Okay? So remember, one way I said is to write the absolute value sign. You could do that. Okay? If you want, me personally, I prefer to just jump right into it and just write 2x plus 4 is equal to plus or minus 6. Okay? So let's just pause right there, okay, and think about what this is going to mean and what we need to do next. Okay? So we're going to treat this just like a linear equation, but we're still going to get two solutions. Okay? So it might be a little bit scary right now, but please don't panic. We're going to get through this together. Okay? So you have 2x plus 4 equals plus or minus 6. So if that plus or minus wasn't there, right, what would I do? I would just subtract 4 from both sides. Okay? So I have 2x is equal to, hang in with me here, negative 4 plus or minus 6. Okay, I'm just going to write it like that, as if they weren't like terms. Okay? And then the last thing I have to do, remember you have a 2 times x, so we're going to divide both sides by 2. Okay? So if you're like, okay, what's going on here? Okay, we can say that x is equal to negative 4 plus or minus 6 all over 2. But wait, there's more. Haha. Okay, so what we're going to do, we have two solutions. I don't really exactly have two solutions yet, so we got to break it down. Okay, I have negative 4 plus 6. This is one solution. This is one possibility, isn't it? Right? And then the other possibility is that I have negative 4 minus 6 over 2. These are just boring old numbers, y'all, so we can actually simplify and evaluate them. So let's try to do that. Negative 4 plus 6 is positive 2. Positive 2 over 2 is 1. So I have x equals 1. That is one solution. Okay, then I have negative 4 minus 6. That is negative 10. Negative 10 over 2 is negative 5. So my second solution is x equals negative 5. Okay, let's go back. Do I have two solutions, just like I said I would? I do. I have two different solutions. I have x equals 1, and I have x equals negative 5. All right, let's look at example 5. So again, I know it's getting kind of tedious now, but I'm asking you, right, how many solutions do you have to, or do you expect to have based on your exponent? So you should have said 2 solutions, because 4 is an even number. Okay, so at this point, we've done a lot of examples. I want to encourage you, when you get to this point in videos, pause the video, work the problem without me, and then unpause it. You know, you can skip through it, fast forward, I don't care, and then see if you are right. You know, try some of these things on your own. If we were in class right now, that's exactly what I would be making you do. I would stop doing these examples, and I would say, try this with a partner or something like that, and I would walk around the classroom and see how you're doing, see if you're picking it up. Okay? So, of course, we're taking the fourth root of both sides. Again, reminding yourself, hey, that's an even root, right? So when I take the fourth root of 81, that is 3. But remember, I'll put it in red so we don't forget, we have to write it as plus or minus, I don't like that color, plus or minus 3. We have to consider both possibilities. Okay, over here, we have 3x minus 9. So 3x minus 9 equals plus or minus 3. Okay, and we're going to proceed just like we did in the last problem. First, I'm going to add 9 to both sides. Okay, so I have 3x is equal to 9 plus or minus 3. Okay, I'm going to divide both sides by 3. Right, and then I have this sort of weird looking guy. Right, I have 9 plus or minus 3 all over 3. Okay, so at this point we want to separate him out, right? So we're going to have the plus solution, which is 9 plus 3 over 3, and we're going to have the minus solution. So that's 9 minus 3 over 3. Well, 9 plus 3 is 12. 12 over 3 is 4. So one solution is x equals 4. Then we have 9 minus 3. 9 minus 3 is 6. 6 over 3 is 2. So my other solution is x equals 2. So as predicted, we have two solutions. All right, let's do another example. So again, before I launch in and start working on this problem, I'm going to look at the exponent. I'm going to ask myself, how many solutions do you expect to have? And because that is a 2, it is an even number, I'm going to expect to have 2 solutions. Okay, so we have 6x minus 4 quantity squared is equal to 45. So, as always, in order to undo the square, we need to take the square root of both sides of the equation. Do you notice anything different about this equation from other equations? Did you notice that 45 is not, in fact, a perfect square? That's a little bit different, isn't it? But that's okay. Let's keep going. So we're going to have 6x minus 4 equals plus or minus the square root of 45. Now, I believe in a previous chapter or section, we have learned how to break down square roots, right? So I always like to do a factorization here. So you can think of 45. 45 is 9 times 5. And of course, 9 is a perfect square, isn't it? It's 3 times 3. So if you rewrite 45 in its prime factored form, we take the 3 and the 3, right? Boop, they pop out. But remember, only 1 3 escapes, so we can rewrite 45 as 3 times the square root of 5. So that's the first change I'm going to make. I'm going to rewrite the square root of 45 as 3 times the square root of 5. Okay, and I have a whole set of videos on that. If you need to, you can go back and watch them and refresh them. Fresh your memory, sorry, not fresh the videos. All right, so now, except for that weird old square root of 5 hanging out there, we're still going to proceed. We're still going to treat this like we have all of the other problems. So we're going to add 4 to both sides of our equation. So we have 6x is equal to 4 plus or minus 3 square roots of 5. And then we're going to divide both sides by 6. Okay, so I need to erase this guy over here because I need some more room. So what I'm going to do is I'm going to write out both, how am I trying to say, both solutions, the positive and the negative. Okay, so I have 4 plus 3 square roots of 5 over 6, right? And then I have x equals 4 minus 3 square roots of 5 over 6. Okay, so these can and must, in fact, be simplified. So I want to warn you of a common mistake that I see over and over and over again. Okay, this is the mistake that I see. I see people do this, 1, 2, right? And then they write, okay, well, x is equal to 4 plus the square root of 5 over 2. Y'all, you cannot do that, okay? You can't just simplify one of those terms and not the other. Instead, what we need to do is we need to rewrite it like this. So we're going to split this up into 2 fractions. So we have 4 over 6 plus 3 square roots of 5 over 6. Because what we're really saying is both terms are getting divided by 6, right? Well, guess what? 4 6, doesn't that reduce? It does. It reduces to 2/3, right? 3 6 reduces to what? To 1/2. Or you could just write that. Okay? So I'm going to give you some options here. Since they don't both reduce in the same way, in other words, they when we reduce them, they have different denominators. Sorry, I don't know why I want to say exponents. I would accept this as your final answer. Check. Perfect points. Okay? I would also accept this as your final answer. Obviously, only one of the two. We haven't done the other solution yet. Okay? So either one of those is fine. Okay, what I'm not going to accept is, again, if you do this and you go 1 over 2, you cannot do that. That is not a mathematically valid operation. Okay, please don't do that. If you don't understand why you can't do that, come see me during office hours. We'll chat, we'll have a good time, and I will prove to you exactly why that is not true, why you can't do that. Okay, so again, if you want to leave this guy alone, I would accept this as a solution. Okay, if you're just a little bit twitchy because you know that 4 6 and 3 6 both reduce, then you could rewrite it like this. Okay, and then we can reduce the 4 6 to 2/3. I'm sorry, I have to erase this because I'm running out of room. So we would have 2/3 minus the square root of 5 over 2. So again, that would be, I would accept that as well. That would be an equally valid answer. Okay, so give me one of these two options. Not both, or, that's an or. Okay, and give me one of those two answers, that or that. Okay? All right, so let's do another example. Okay, so this time, again, I forgot to mention, to ask how many solutions we have, but we can see that we have a third power here, so we are expected to have 1 solution and not 2. But again, as you look at this, you can see that it's a little bit different from things that we've seen in the past, right? In fact, if we go back and look at this, right, we can see that we have just the squared term and nothing next to the squared term, right? That's how all of our previous examples have been. This one's a little bit different because you have this cube, x plus 4 quantity cubed plus 6, okay? So the first step, as you can see down here, is to isolate the exponential term. In other words, it's not really an exponential term. The term that's being raised to the power. Okay. So I'm going to subtract 6 from both sides. Again, I'm sorry. I really shouldn't call it an exponential term. I'll just say the term with the exponent. An exponential term means that you would actually have x or a variable in the exponent, which obviously we do not have. Okay, so we have x plus 4 quantity cubed is equal to negative 125. Ooh, this is interesting. We've never had a negative on the other side before, right? But again, this is starting to look like what we're used to seeing. So we'll take the cubed root of both sides. You can use a calculator or your brain, and the cubed root of negative 125 is negative 5. If you don't believe me, you can say that negative 5 times negative 5 times negative 5 is negative 125. You can prove that to yourself. And then, of course, over here we just get x plus 4. Okay, so we're going to subtract 4 from both sides, and we get x is equal to negative 9. Again, we anticipated that we would only have one solution, and that is true. All right, let's do another example. All right, so this one, again, the first thing I'm going to do is ask myself, I'm going to ask whether I have 2 solutions or 1. And again, looking at the squared, I see that I expect to have 2, not 1, solutions. Okay, so this problem is similar to the one we just did in that we have this minus 6 right next to the, not exponential term, but the I'll just say a polynomial that is squared. Right, 6x plus 1 is being squared. So the first thing I need to do, just like the last problem, is I'm going to get that squared term by himself. So we have 6x plus 1 quantity squared is equal to negative 4. So this is where I think it starts to get really interesting. All right, so I'm going to take the square root of both sides. Okay, so do you notice anything here? Do you notice anything a little bit weird or different? Did you notice that we're trying to take the square root of a negative number? Well, we can't really do that, right? What is the square root of negative 4? Well, remember, you learned in a previous section that you really rewrite this as the square root of negative 1 times the square root of 4. Remember, we have a special way of expressing the square root of negative 1, which is I. And then with the square root of 4, right, remember we said that that could be plus 2 or minus 2. So the square root of negative 4 is plus or minus 2i. Okay, so this is the first example that we've done in this video so far that had a complex solution. Okay, but it's actually very similar to how we've solved all the other ones, right? So we're going to subtract 1 from both sides of the equation. So I have 6x is equal to negative 1 plus or minus 2i. Then we have to divide both sides by 6. Okay, so we have x is equal to negative 1 plus or minus 2i all over 6. So if you, just really want to leave your answer just like that, I am totally fine with that. I believe some online software programs ask you to split it up into 2 solutions. So let's do that just for practice. So we would have negative 1 plus 2i all over 6. And then we would have negative 1 minus 2i all over 6. The last thing I want to leave you with, because sometimes I believe some software asks you to write your answer in the form a plus bi, I want to say. Okay, so let's think about how I could write those as a plus bi. Okay, so what I'd have to do here, I'm going to erase, I just need some more room here. I could rewrite this as negative 1/6 plus 2i over 6. Do you see anything we need to reduce here? Well, we need to reduce that second fraction, right? So we would actually have to rewrite this as negative 1/6 plus 1i over 3, or I over 3. Okay, likewise here we would have negative 1/6 minus 2/6i, which of course becomes negative 1/6 minus 1/3 I. Okay, so the expressions that I've circled, they are all equivalent mathematical expressions. So again, for me, I would give you full credit for any of those unless the directions are more specific. But again, in the software, like the online homework, which I don't write the directions to, if they do ask you for something that's in the form a plus bi, then this is what you would need to type in. All right, let's do another example. So again, we're looking at our exponent, and we're asking ourselves, hey, self, how many solutions do we expect to find? And since it's an even exponent, we expect to find 2 solutions. Okay, again, our term that has the squared part on it is not all by itself yet, so we want to get him all by himself. We'll do that by adding 3 to both sides. So we have 2x plus 1 quantity squared equals negative 18. Okay, so then we need to take the square root of both sides of the equation. Okay, so that gives me 2x plus 1 equals plus or minus the square root of negative 18. So we have 2 things going on here. First of all, we have a negative sign, right? So we're going to rewrite the square root of negative 18. We're going to rewrite it as the square root of negative 1 times 18. And remember, this guy, he becomes I. But the other thing we have going on here is that 18 is not a perfect square. 18 is 9 times 2. So we have I times the square root of 9 times the square root of 2. Well, the square root of 9, of course, is just 3. So the way I would write this, it's a little bit weird, but we would write 3I times the square root of 2. That's how I would write that. Okay? Again, if you're a little bit fuzzy on imaginary or complex numbers, just go back and watch those videos. Just take a minute and review. Okay? So don't forget your plus or minus here. I kind of dropped it in that little example there, but it is plus or minus 3I times the square root of 2. Okay? So hopefully, by this point, you're feeling pretty comfortable, and this is feeling very familiar, maybe even a little bit boring at this point. So we have 2x equals negative 1 plus or minus 3I square root of 2, divide by 2, divide by 2. So my final answer is x equals negative 1 plus or minus 3I times the square root of 2 all over 2. Okay? Now, as I said, you might be asked to split this up into 2 solutions. You might also be asked to write it as a plus bi. So let's just take a minute and do that. So as you can see, I switched to a new page because we're out of room on the other page. So my positive solution is going to be x equals negative 1 plus 3I square roots of 2 over 2. Okay, and if you're asked to rewrite it in a plus bi form, you could rewrite it as negative 1/2. That's your a, that's your real part, right? Plus bi, so that's going to be 3I square roots of 2 over 2, right? So just in case anybody asks you, your a would be negative 1/2, and over here your b would be 3 square roots of 2 over 2. All right, so just hopefully that is helpful. So then we need our negative solution, so that would be negative 1 minus 3I square roots of 2 all over 2. Okay, again, if you need to break it up, if you're asked to break it up into a real and an imaginary part, you could break it up like that. And again, if anybody asks you what is A and what is B, A, of course, is going to be the same, and B is the same except for it is negative. Okay, so it would be negative 3 square roots of 2 over 2. All right, we have a few more examples here. So here we have 3x squared equals negative 48. So again, the first thing I want to do, I want to ask myself, how many solutions do I expect to find? Well, I want to find 2 solutions, okay? Right, because it is x squared. So this one's a little bit different as well, right? Can you think about what we want to do first? Do we want to take the square root of both sides first? Okay, so the answer is no, we do not. What we want to do is we want to divide both sides by 3 first. So we have x squared equals negative 16. So again, exponential term is not correct. We want to isolate the term that has the exponent in it. Okay, so now we can go ahead and take the square root of both sides. Okay, so again, right, think about the square root of negative 16. Well, that's really the square root of negative 1 times the square root of 16. So remember, this is I, and of course the square root of 16 is plus or minus 4. So we have x is equal to plus or minus 4i. Wasn't that nice? Okay, and again, if you have to rewrite it in two different solutions, you could say either x is equal to 4y or x is equal to negative 4i. Okay, if you had to write it as a plus bi, well, notice there is nothing in place of a, right? So you would be 0 plus 4i and 0 minus 4i. So that would be your two solutions if you have to write it in that form. All right, example 11. Oh my goodness. All right, so once again, we want to isolate not the exponential term, but the term that contains the exponent. So 2x cubed equals negative 54. So I'm going to divide both sides by 2, and we get x cubed equals negative 27. Oh, I forgot to do the thing. So how many solutions do we expect to find? Well, we expect to find one solution. Okay, so I'm going to take the third root of both sides. Okay, remember when you take an odd root of a negative number, it's cool. You do not generate an imaginary number. So the third root of negative 27, you can literally just type this into your calculator. You get negative 3. If you don't believe me, try this. Negative 3 times negative 3 times negative 3 is negative 27. Try it on your calculator and you will find out that it is true. Okay, I believe this is the last question here. So we have 5x squared minus 3 is equal to 17. So I'm going to add 3 to both sides. Then I have 5x squared is equal to 20. I'm going to divide 5 by both sides. Again, this is not an exponential term. It's a term that contains an exponent. So we get x squared is equal to 4. Take the square root, take the square root. Oop, I forgot to do the thing. Right, we have a even exponent, so that means we expect to have two solutions. So we have x is equal to plus or minus 2. Or if you want to write it like this, x is equal to 2 or negative 2.